In the last video, I talked about plotting points in the polar coordinate system, which we found out was a very mechanical, simplistic process. But now we're going to step it up a notch, and we're going to work with converting, rectangular points to polar points, or polar points to rectangular points. And maybe in this video, I'll be able to convert equations as well, but we'll see how far we get. So one thing I want to point out is that there's a series of formulas we have to know. And, just with math, it's just more formulas to remember. I'm sorry, but knowing these equations is extremely important in order to ensure your success in working with polar coordinates. And I'm just going to kind of jot them down, and I'm going to leave them in this top right corner the whole time, just for our own reference. So we have x is equal to r cosine of theta. X is equal to r cosine theta. Y is equal to r sine of theta. R sine of theta. Then we have tangent. So we have tangent, or we have theta. Sorry, theta is equal to tangent inverse, just y over x. And you can see here, this is if we're working with polar to rectangular, this is how we're going to get our x and our y. If we're working from rectangular to polar, this is how we're going to get our theta. And to get our r, we can just know that r is equal to the square root of x squared plus y squared. Or we might even have to use r squared is equal to x squared plus y squared. So these are formulas you definitely have to remember. I highly advise it. Just after using these enough, you'll get the hang of them. Sorry about that. You'll get the hang of using these, and you'll just know them like the back of your hand. So, there's really not much theory behind this, and I don't really want to go too much into theory. I just want you to know, how to do this, for your homework or your exam. Like knowing how to do this and implement these formulas, it's really what's important as math students. And, understanding it is as well too. But, for these videos, I'm not trying to go too much into the theory, just in order to provide you with the instructions on how to do these things. So, these formulas are going to help us travel between the rectangular world and the polar world, or the polar world and rectangular world. So these are your key guides in getting between those worlds, and definitely don't forget them. So let's just kind of jump right into an example here. Let's say I was asked to go from polar to rectangular, and I'm just given this polar point. All I'm given is 2, comma 3 pi over 2. So what I want to do, I want to convert this polar point into a rectangular point. Well, how on earth can I do that? Well, you're going to find out that going from polar to rectangular is actually pretty easy, because the formulas, that they're already set up for us. Because remember that in polar coordinates, this is this guy right here, this is r, and this guy over here is theta. So all we have to do is, it's really just a matter of plug and chug. So I'm going to use this formula on the right, to find my x value. I'm going to say x is equal to, well, remember it's r cosine theta. Well, what's my r? My r is just 2, and theta is 3 pi over 2. So 3 pi over 2. So I get 2 cosine 3 pi over 2. Well, cosine of 3 pi over 2 is just 0, so I get 2 times 0, and so that's just 0. X is just 0. So we already have our x. Now we just need our y. So let's find y. Remember, y is equal to y is equal to r sine theta. So in this case, r is still 2, and we'll be taking sine of theta. Theta is just 3 pi over 2. 3 pi over 2. And all we have to do is just evaluate that. Well, remember that sine of 3 pi over 2 is just negative 1. So we would just get negative 2. So we get x, x is 0, and y is negative 2. And our point is just 0 comma negative 2. So that's our answer. Our answer is 0 comma, -2. And that's the polar coordinate of this graph. Or I mean, that's the rectangular rectangular coordinate of this polar coordinate right here. Same rectangular point of this polar point. That's really all it is. So it's pretty simple. Polar rectangular is a very, very easy process. It's just plug and chug. So let's just do another example right here, and then we'll move on. So let's say I was given same instructions as before, just polar to rectangular, -1, -pi/6. Okay, well, let's use the formulas. X is equal to, remember, r cosine theta. X is equal to r cosine theta. R is just -1. Theta is -pi/6. So now we just have to evaluate this. So we're just going to do -1. Well, what is cosine of -pi/6? Well, cosine of -pi/6, that's just rad3/2. So my answer is just going to be negative rad3/2. And that's my answer right there. So now we're just going to find our y value. Remember, y is equal to r sine of theta. So, the r stays the same and our theta stays the same. We're just taking the sine instead of cosine of the -pi/6. So -1 times sine of -pi/6. So now I'm just going to scroll down a little bit. And then we get, well, sine of -pi/6. That's just going to give me -1/2. -1/2 times -1, that's just going to give me a +1/2. So my y is 1/2 and my x is negative rad3/2. And that's it. So, my answer here would be negative rad3/2, comma, 1/2. And that's it. That's the polar point as a rectangular point. So pretty simple process. For polar to rectangular, very easy. It's just plug and chug. Just plug and chug. You just plug r in, you plug theta in. You memorize these two formulas over here. These two are crucial. And really, it's just a pretty simple process. So polar rectangular, that's the easy part. That's easy. It's just free points on your test or free points on your homework or whatever. So what if we go the other way around? And the other way around is a little more involved, but it's something we should be comfortable with. So let's try that. So I'm not gonna clear the board like I usually do, because I don't want to get rid of all of those formulas I have up there, because those are pretty important when we're working with polar coordinates. So let me just clear all this stuff out. All right, we're all set. Okay, so what if our instructions then said, hey, I don't want you to convert from polar to rectangular. I want you to go from rectangular, and I'm just going to say rect, to polar. So rectangular to polar. And this is where they'll provide for us, just a rectangular point. Let's just say they provide us with -4, 4. Well, what we need to do is we need some way to get this. We need some way to get theta, and we need some way to get r, because our goal is to get, we need some way to get, our goal is to get r and theta. We need some way to get this. So let's think about that. Well, remember the formula. We can definitely get theta right off the bat, right? Because remember, theta is tangent inverse y/x. This is x, this is y. So I can do that. I can do that really easily. So I'll do tangent inverse y/x, just 4/-4. And that becomes the same thing as tangent inverse of -1. And one thing that confused me when I was first learning this was, how do we know, what angle it is? Because that -1 can be produced by tangent in several quadrants. So how do we know which quadrant we're working in? And to get that answer, you really just sketch where this point is. -4, 4, that's over here. So we know we're in quadrant 2. So what angle in quadrant 2 would give us a -1? And the answer is just 3 pi over 4. And again, like I said, polar coordinates is something you have to be very, very comfortable with your trigonometry with. I'm doing tangent inverses, I'm converting back and forth just like that. So if you're not strong in your trigonometry, I highly advise you to strengthen those skills before working with polar coordinates. Otherwise, there's going to be a really big learning curve when you're dealing with this. So we definitely have our theta right here. There's our theta. Now we just need to find r. So let's do that. So we know that r is equal to the square root of x squared plus y squared. So all we have to do is really just plug in. R is equal to, well, remember my x is -4, so -4 squared plus 4 squared. And I'm going to get the square root of 16 plus 16, and that's going to give me rad 32. And if you really want to simplify this down more, you'll know that this will simplify into 4 rad 2. So this is my r value. This is my r value. And that's all there is. That's all there is to finding this. It's really pretty easy. So what I'm going to do is I'm just going to write my final answer as, remember, it's r and then theta. So 4 rad 2, comma 3 pi over 4. 3 pi over 4. And we're done. Let's say though that I was not only asked to convert, but I was also asked to find another point that means the same thing. Well, I can do exactly that. Remember what I said earlier. I said if you want another point that represents the same, or you want like another way of representing the same point, you could always just flip the signs on your r, and then you add pi. You add pi to whatever your theta is. So 3 pi over 4 plus pi, that's going to give me 7 pi over 4. So these are two different ways of writing the same point. There are two different ways of doing the same thing. So not too bad. This is really just plugging in as well. It's just a little more to plug in, especially because you have to recall, tangent inverse. But you really just do tangent inverse of y over x, and then all you do is you just plug x and y into your r equals square root of x squared plus y squared. And that's really all there is. So this is my answer down here. And I think we have time for one more example. One more example for converting between rectangular and polar. So I'll do that really quick. And I'm just going to clear the board entirely because I feel like we're comfortable enough with these formulas now. Okay, so let's say I was given, I want to go from rectangular to polar, -6, comma 0. -6, comma 0. So I'm going to do exactly that. Let's say I first want to find, let's just change it up a bit. I want to find my r. Well, remember that r is the same thing, that's the same thing as x squared plus y squared. Same thing as square root of x squared plus y squared. So to find my r, I'm going to do -6 squared plus 0 squared. -6 squared becomes 36, plus 0 is still 36. So I get the square root of 36, which is just 6. So I have my r value. I got it pretty easily. Oops, sorry, r. There we go. Okay, so now let's find theta. Remember that theta is equal to tangent inverse y over x. Well, my y value is just 0, and my x value is -6. But this is the same thing as just saying tangent inverse of 0. But remember, we don't know which angle we're referring to. This could mean a few different things. So I just want to roughly sketch where this point is, this xy point is, and it's at -6, comma 0. It's over here. It's over here. So the angle that gives me this is just pi. It's just pi. So I get pi as my theta value. And that's it. So in summary, I would just write as my answer 6, comma pi. pi is my theta, 6 is my r. And then again, let's say we were asked to find, let's say we were asked to find just a different way of representing this point. So remember, you could just flip the signs, add or subtract pi, add or subtract pi. Before we added pi, let's subtract pi this time. Negative 6 comma 0. Negative 6 comma 0, that's fine. Or you could say negative 6 comma 2 pi. You could add or subtract pi, doesn't matter. So flip the signs, add or subtract pi. So these all mean the same thing. Some books might just want you to write your answer in 3 different forms. It really doesn't matter. It really doesn't matter. So hopefully this helps you a little bit. If you're having some trouble with this, I recommend just going back, looking at those formulas I wrote down, and remember those because those are really your guides in converting from rectangular to polar and vice versa. Those are the formulas that are going to get you through this chapter, and they're going to help you do well on your exam because if you know them, you'll be able to do you'll basically be able to do all of the conversions between rectangular to polar, or polar to rectangular points, and like we're going to do soon in the next video is we're going to convert between rectangular to polar equations or polar to rectangular equations. And I'll do that in the next video. I don't want to make this one too long, but I'll have that one up shortly as well.